In this section, we'll explore how layouts can arrange and size items, focusing on row layout, column layout, and grid layout. We'll compare these layouts with their positioner counterparts. Our project will involve building a simple image viewer that displays thumbnails, allowing you to select an image for a larger preview and display image details below. As we move into methods that can affect position and sizing, we must specify how we wish to size the content if we are constraining the layout size. We will follow an outside-in principle where the layout is constrained first by the window, and then content adjusts within it. Start by creating a new project called Layouts, as we did in the previous sections. Go to File, New Project, and select Qt Quick Application. Name it Layouts, and use the same settings as before. As before, make the window larger and change the title to Hello Layouts. To use the layout types in our QML file, we must first import the qtquick.layouts module. In this project, we'll also use the application window and label types from Qt Quick controls, mainly to set the palette.window text color role on the application window and have all our labels use that color role, avoiding lots of code duplication. So we'll import Qt Quick controls using the basic style. Next, change the window to an application window and give it an ID, window, which we'll use later. Start by setting the background to black and the window text palette role to white. We will also add a property, current image index, and set it to 0, which we will use later to store the selected image index when an image thumbnail is clicked. As with the previous sections, we will copy the same assets and add them to our project. Copy the assets into the Layouts folder and then add them to the project using the Add Existing Directory option. Select the Assets folder, and now the assets will be available to us in the project. First, we'll create the same basic image component that we've used before, but with a couple of modifications. Start by creating a component and naming it Thumbnail Delegate. Inside the component, declare an image item and give it an ID of thumbnail. We will then add a required integer property called index, setting the image source using a template literal with a placeholder containing the index. We will also set asynchronous to true. Next, we'll visually indicate if the thumbnail delegate has been selected by adding a border around it. The border will fill the parent, have a transparent background, and have a white border color. The border width will be 2 when current image index matches the thumbnail index, otherwise it will be 0. As before, to see which image is positioned in which order, add a label inside the image. The label will be centered in the parent, have a font pixel size of 30, an outline in black, and its text will display the thumbnail index. To make the thumbnail clickable, add a mouse area as a child that fills the image. For its on-clicked handler, set window.currentImageIndex to thumbnail.index. Layout types, like positioners, size themselves around child items based on their implicit size and any layout-attached properties, such as preferred height or preferred width. These properties provide greater control over item positioning and sizing, offering options to specify minimum, maximum width and height, as well as fill width and height. Alignment within layouts is centered by default, but can be affected by utilizing similar principles to anchoring. Additionally, there are margin properties to add additional space on specific edges or all edges of the layout using the margins property. Grid layouts allow for precise positioning using row, column, and stretch factors. We'll explore these layout properties in more detail as we move forward. To complete the image thumbnail with layout-attached properties, we're going to set a preferred width and preferred height on our image thumbnail. This will ensure that any layout containing instances of the thumbnail delegate knows how to size it. Let's set the layout preferred width and preferred height to 100. Now that we have created our thumbnail delegate, let's introduce layouts to organize our content and add some visual structure to the application. First, we'll add a row layout that fills the window with a margin of 5, matching the default layout spacing. Unless specified otherwise, all the layout types have a default spacing of 5 pixels. We will use this margin value throughout the rest of the project. Inside the row layout, add a flickable with an ID of flickable. Then, inside the flickable, add a grid layout with an ID of grid layout. The grid layout will appear along the left-hand edge of the window, extending from the top to the bottom. The flickable will allow us to scroll vertically if the window is resized too small to show all the image thumbnails we'll place in the grid layout. The remainder of the window area will be occupied by a column layout. This will include an image with an ID of preview image, which will display a large version of the selected thumbnail image, filling the majority of the window area. Finally, we'll add a small row layout containing a row of 10 labels showing information about the image. Let's take each of the elements we just created and fill out their properties, along with any layout-attached properties we need, to size and position the items we want the layouts to manage. For the flickable, we need to add the following properties: setting content height and content width to the grid layout height and width respectively. We also want to set layout.fillHeight to true to ensure the flickable fills the height of the row layout, and layout.preferredWidth to grid layout.width to ensure the flickable's width always matches the grid layout's width. Additionally, we'll set clip to true to ensure the flickable doesn't draw within the gap between the application window and the parent row layout's margins. The grid layout will require setting the number of columns. In this case, we'll set it to 2. Grid layout behaves much like a row layout or a column layout when the number of rows or columns is set to 1. Grid layout considers the layout attached properties as applying to the cell rather than the entire layout. If you think of row layout as being only 1 cell high and column layout as being only 1 cell wide, this makes sense. Grid layout can also use the additional attached properties layout.columnspan and layout.rowspan, which only apply to a grid layout with more than 1 row or column. Unlike the grid positioner, there is no default value for the number of grid layout rows or columns. Grid layout also supports layout direction and flow enumerations in the same way as the grid positioner type. Simply use the grid layout prefix for the flow enumeration types instead of grid. Inside the grid layout, we will add our familiar repeater, creating 10 instances of the thumbnail delegate. The thumbnail delegate already has layout-attached properties, so these will be considered by the grid layout. Now let's look at the preview image. We want the preview image to fill all the available space, so we set layout.fillWidth and layout.fillHeight to true. To display the selected image, we'll use the following URL binding using a template literal with a placeholder to find the current image by appending current image index to the string. We'll also set asynchronous to true for performance. For the row layout with the image details, we want to reserve some space at the bottom of the window, so we'll set layout.minimumHeight to 40. Finally, for the labels, we want to use them in pairs. The first of each pair will be a title, and the second, a value. For the first label, we'll give it the ID source title and the text source. We also set the font to bold. For the second label, we'll give it the ID source value and set the text to the source URL of the preview image. We can then do the same for the remaining 4 pairs of labels for width, height, painted width, and painted height, setting the IDs and text properties using the same pattern. Let's now look at the finished application, which should look something like this. We can select the image from the grid layout, and we can see the source properties at the bottom of the window showing the details of the selected image. Notice how changing the size of the window changes the size of the preview image, and consequently, the painted width and height properties in the details. Also, note how the grid layout remains the same width, but as its height varies, using a flickable allows us to scroll the grid layout vertically. A key thing to remember when using layouts is not to use anchors on items that are direct children of layouts. You should always let the layout do its job. If you accidentally do this, you will receive a warning at runtime. You might want to try this yourself to see what happens and then make a conscious decision not to do it. Be careful about what items are managed by layouts and those managed by anchors, and avoid mixing the two. Layouts allow you to arrange and size items in a row layout, column layout, or grid layout without needing to reference the ID of any neighboring item. Layout mirroring also works with layout types, as discussed in the Positioner section. The layout-attached properties provide a great deal of control over the positioning, alignment, spacing, and sizing of the items under a layout's control. Additionally, layouts can be nested to create comprehensive and dynamically resizing arrangements. However, there are some cons. Layouts don't support add, remove, or move transitions like positioners do. In some cases, layouts can only do their best to adhere to the sizing hints, and sometimes the layout engine has to make compromises, which you may need to consider. When constructing complex layouts, it can be challenging to understand how an item's sizing policy is actually being manifested in the rendering. The best way to understand how layouts work is to try them out yourself. So why not experiment with layouts and see what kinds of arrangements you can design?